Today I am going to discuss about the fundamental concepts of thermodynamics. So first we should know some basic definitions like what is the temperature, pressure, the volume, and the work, heat, energy. So all these things. So first coming to the temperature. So temperature is it measures the degrees of coldness or hardness of a body. So the zeroth law of thermodynamics, that is the basis for the measurement of the temperature. So first, what is the zeroth law of thermodynamics? Suppose if we take the two bodies, one body A and another body B. So these are in thermal equilibrium. So thermal equilibrium means so both the temperatures are the same, and another body C. If B is in equilibrium with C, then A and C must be in thermal equilibrium. So this is the basis for measurement of the temperature. And the temperature measuring devices, so those are operated based on some properties like those are called as thermodynamic properties. Suppose in general the temperature is measured with the help of the thermometer. So thermometer the thermometric property is the volume of the gas or liquid, and constant volume pressure. Here constant volume gas thermometer, here the thermometric property is the pressure of the gas at constant volume, and thermistors. So these are also the temperature measuring devices. Electric resistance of the solids, and thermocouples, electromotive force, of the metals, and next pyrometer, thermometric property is the intensity of radiation. So generally temperature of a body is measured with the help of these devices: thermometers, constant volume gas thermometer, thermistors, thermocouples, so pyrometers, and the thermometric properties. So that is the volume of the gas or liquid that is used to measure the temperature in a thermometer, and similarly pressure of the gas at constant volume. So that is the thermometric property for finding the temperature. Similarly, electric resistance of the solids, that is the thermistor, and for thermocouples, electromotive force of the metals, and pyrometers. So generally the pyrometers are used in the industries to measure very high temperatures. So where the thermometric property is the intensity of the radiation. Now coming to the temperature scales, we have 4 temperature scales. One is Celsius scale, temperature scales. So we have four one is Celsius, and second one is the Kelvin, Fahrenheit, and Rankine. So these four are the generally used temperature scales. So for each one, this is a steam point, ice point, and absolute zero. So for each scale is divided based on these three points: steam point, ice point, and absolute zero. So first, what is a steam point? The steam point is the boiling the point of the water, and ice point is the freezing point of the water, and absolute zero, it is a minimum temperature which we cannot be lower the temperature of the body. So if you take the Celsius scale, the ice point of the water is 0 and the steam boiling point of the water is 100. So first the thermometer is kept in a ice beaker, and that mark is set as the 0. Then the same thermometer is kept in a boiling water and it reads 100 degrees Celsius. So that is the steam point, and that is marked as 100, and then it divides into 100 equal parts. Each part is equals to 1 degree Celsius. And similarly for the Kelvin, the scale, for Kelvin scale, so this is 0, 273.15 and 373.15 Kelvin. For Fahrenheit scale, this is 212 degree Fahrenheit. Ice point is a 32, and this is minus 459.67. Similarly for the Rankine scale, the steam point is 671.67 Rankine, and the ice point is 491.67, and this is 0 degree 0. This is the rank absolute 0. So most of the industries, or for in thermodynamics we are using the Kelvin scale for calculating the work or pressure. Most of the industries follows the Kelvin scale. And now coming to the pressure. Pressure. The force exerted per unit area is defined as the pressure. So P equals to force per unit area. Suppose if the force is generally denoted with a symbol, units for the force is Newton, and area is the meter square, and we can write F equals to, according to the Newton's laws of motion, force equals to mass into acceleration by area, or mass can be written as H V and H A rho, and this is A, and A get cancelled, and we can write H rho A, or A is nothing but the acceleration due to gravity, H rho Z. So the pressure of a fluid is finding out with the help of the equation P equals to H rho G. So for measuring the pressure, we have so many devices like barometer, manometer, inclined manometer, and McLeod gauge. So many equipments are there. So now coming to the next property is the volume. So volume is nothing but the product of the lengths is the volume, and it has the units the meter cube, and it is dependent, volume is dependent on the mass or amount of the substrate, depends on the material. But specific volume, if you take the specific volume, the specific volume, it is nothing but volume per unit area. Volume per mass, unit mass. Volume per unit mass is the specific volume, and it is independent of the material. So the units for the volume is meter cube, and the units for the mass is kg. So meter cube per kg, this is the units for the reciprocal of the density. So the specific volume is represented with the symbol V. This is equals to 1 by rho. 1 by rho is the density, because the units are the same for the volume. The reciprocal of the density is equals to the specific volume. So now coming to the next terms of work.